Hello everybody and welcome back. So we're going to continue on from our last lesson building our save scene script, and we were up to the point of having our version number set. So now we needed to fill in the final piece of information, which is the username. Obviously this is important because we need to know who worked on it last, so that you can see when the scene has changed hands, or if you need to talk to anyone about maybe taking over from their scene and then continuing. Right, so the username is something that gets stored in Houdini automatically. Obviously, if you're in your pipeline, whether it's in a small studio or at work or wherever, is being set. It can be overwritten and set manually by whatever pipeline you guys have, but it will automatically also exist with just your sort of computer's username as well. So just under user, you'll see that there is something there. Okay. There is also username, which here appears to be the exact same thing. So I'm not sure, maybe on different machines it'll be different. So you can always see what it is on yours before committing to either one of these. In this case, I'm just going to use user. If yours is different, then obviously just pick whichever one you want. Okay, so I'm going to come in over here and we're going to grab that environment variable. So we're going to say user equals, and then I'm going to get my environment variable, which was user or username, depending on which one you use. And something I want to do here very specifically is go and give this lowercase. Right, so I want to just say dot lower, and that will change that string no matter what it comes out as. It'll change it to all lowercase, because I want to keep one case throughout the entire name of this. It's just so much easier to work with when everything is in a shared case. So lowercase is just the easiest to work with, right? And because we do, in our naming convention, we do allow underscores. You don't need something like camel case to separate different words. You can just put an underscore. So that's kind of the convention we're going with here. Right. So we're going to grab our username from that. So that's a really, really simple one. But now what I want to do is I also want to go and kind of clean up all of the names of these components that I've got here, right? We've been basically assembling all of these different pieces of information. I've got my username, I've got my version, I've got we've got the task, we've got the descriptor, and then we also have the scene, okay? And it's going to be much easier to work with all of these if they are, first of all lowercase. But we also need to make sure that they don't have any leading or trailing empty spaces. We need to make sure that they don't have any special characters, and that we do use underscores instead of any, for example, white space or special characters. So, which especially means something like dashes as well, which will pick up as special characters, because we are going to join separate parts of these components using dashes. If we allow our user to put dashes in the names, then it's very hard for us to determine the when does the scene name end and when does the task begin, because we're telling it to grab a certain name. Well, okay, not in this regular expression, but in another one that we will build later, when we're almost disassembling the scene name as it is saved in order to pull apart all of its components to figure out how to save up the next version. We need to know when the scene name ends and the task begins. If scene name has a dash in it, so if it was new dash scene and then dash explosion, how do you know which one is the task and which one is the scene? Is the scene just called new and then the task is scene dash explosion, or is it new dash scene and then the task is dash explosion? So it's very difficult. We have to enforce some kind of system here. So this is just the one that I've chosen to go with, is basically using dashes to separate different pieces of information using underscores within. And we need to enforce that. So if up till now we've been able to allow things like the the user to input a task and that task is not cleaned up, well, now we're going to do that. But in order to do this properly, I mean, we're going to want to do it across all of these components. So we might as well build an additional function. So we've done stuff like this before. This is something, a utility function, but it's utility within this script, not global utility. So I'm not going to embed it in my utility scripts. It's just something for this scene. So I'm going to call this one a clean name. It's because we're just cleaning up the name, and we will take a string. So we're going to take in the name, but spit out a new name that has been cleaned up. And there's just a couple of things I want to do here. So I want to take that string, and the first thing I want to do is make it all lowercase. Okay, so we just want to convert that to lowercase. And then I also want to strip out, so there's a dot strip, which takes away the leading and trailing white spaces. Okay, so if there is a space at the end of it or a space at the beginning, it just strips that out. Okay, so these are two very simple ones we can apply even in one line. But I'm going to store this as new name. Okay, so we're going to apply it to a new variable called new name, and then we'll return new name at the end. Now, what I want to do here is I want to remove all special characters from this and replace them with an underscore. Okay, because we cannot allow any special characters except underscores, right? And underscores do count as word characters in regular expressions. But what we want to do is find all non-words and non-word characters and turn them into underscores. So that will mean white spaces will be converted to underscores, but also things like other dashes or weird characters, you know, a $sign or a star or something like that. Okay, so the regular expression that we're going to build is very simple, so simple that we're not even going to dive into regex 101. We're just going to do it directly here because we're basically using a single thing, right? So we're doing \W, right? Which capital W is basically saying a non-word character, right? So if we find a non-word character, but what if we find multiple in a row? Okay, so what I want to do is put a plus, because I want to say if we find one or more non-word characters in a row, convert them all to a single underscore. If we go and replace each of them, so if we don't include the plus, then this is, if there was a, let's say, a $sign and a space and then a star, there would be 3 underscores, and that just looks terrible in our naming, right? We don't want to do that. So we're going to go and say with a plus, meaning one or more. So find at least one special character, then convert it to an underscore. But if, and this is greedy because we're not putting a question mark, right? So with a plus, it's greedy. If we found 3 special characters in a row, it's going to make one match object, and we're going to do a re.sub function here where we replace every match with an underscore. So if it matches 3 in a row, still swaps it for only a single underscore. Now, what we can do in here is we can put an additional backslash to make sure that we escape the first backslash. But I'm going to show you another method just to remind you of our raw string format so that this will work as well. If we just put a lowercase r in front of our string, then the string is represented as raw. So it will not sort of use the backslashes as special characters in Python string syntax. So it just treats that backslash as a backslash. It doesn't actually look at \w the same way that it looks at, you know, for example, like here, \n. Okay, it's not a special character. It just reads each character as is. So popping a raw, just an R in front of the entire string means we don't have to do anything else with it. Okay. Now we couldn't do that with our previous one over here because we want to obviously go and replace these with special characters. So we needed to do some special things over there. Okay, so now we have our regular expression, and we're just going to say new name equals, and then we do a re.sub, because remember sub, it substitutes all the matches for whatever we feed it to replace with, but it returns not another match object, it just returns the name, the altered string. Okay, so we can just store it in our new name. Now what we feed it first is the regular expression, and then we feed it what we want to substitute with, so an underscore, and then finally we give it new name, because that is the thing that we're looking for. Now we can go through and make it non-case sensitive, but in this case there's no purpose to that. First of all, everything is lowercase, but also we're looking for a total wildcard. We haven't given it anything that is case sensitive in the first place, so we don't need to include that flag. And then here now we will just return our new name. Okay, so this function is just going to clean up whatever string we feed it. And now when we go back down here, we're going to basically create a list of all of our components, clean them up. But then another reason why I'm putting this into a list instead of just applying this to each, for example, our scene, our task, our version, our description, and our username. Those are the 5 bits of information we have. I want to put them in a list because I want to join them with a dash. And an easy way to join something with a dash or any character is to do a string join function. But something else really cool about this is, I'm just going to type an example here just to point something out to you, right? So we would have our scene. Let's, for example, I'm going to call my scene, scene. I'm going to call my task, tasks, just so that it's easy for you to see what we're doing. So we're going to have scene dash task dash version. So I'll just call that VO1. Then description, okay, dash user. Okay, so that is the name we are trying to assemble. 5 pieces of information. But what happens if this description is left blank? What if we leave it out? Okay, so the user provided an empty string for this, and we allowed that. We did say that it was okay for the user to give us an empty string for the description. Well, it'll still be empty, and so it'll just look like that. And we end up with 2 dashes in a row, which is not what we want. Okay, this would be if we went and joined this with something like using the string formatting. So we would go scene and task, and then we would go, do that for everything here, and then go at the end dot format, and go and just replace scene equals scene and task equals task, and so on. And do the same for all of them, including description. Right? We'd have something like that, like DESC, and then we'd go DSC equals, and then we'd feed it our descriptor. But the problem is, if the descriptor is empty, an empty string, it still feeds it in, so we end up with 2 dashes, right? There's no way to tell it, hey, well, if you don't find one, then don't add this other dash, because that dash is implicitly there, like it is, well, it's explicitly there, sorry. It has just been typed in, it's not part of the variable. Another way of doing that, though, would be to include the description without a dash. So we'd do something like this, and then we'd have to append the description to a dash as well before feeding it in here, and that's just a bit messy as well, and I don't really like that method. So instead, what we do is, if we assemble a list, then when we assess our description, if it's empty, we just delete it. Because when it's deleted from our list, if we join it using dashes, that item is not in the list, so it will not join it. So it's not going to join it to nothing, to an empty string. We have simply removed that component entirely. And so it will not have a double dash. It'll only be a single dash, because it's going to join the version number to the username. Okay. So you'll see how that works now, but basically there's 2 main reasons why we're doing a list. Primarily so that we can keep it nice and neat when we clean up all of these names, but secondarily so that we can also assemble them without getting a double dash. So our components equal, and then we're going to create a list, right? And this is an ordered list, okay? So we're not doing a set or anything. It's very specifically an ordered list because the order matters. Okay, so it's scene, then task, then version, then descriptor, then user. Okay, and now we loop through this. But because we're going to want to alter our original list, we need to know what index we're working with. So we can't just do for C in components, because then we only have access to that actual variable. We do not have access to what index we are looping over at the current moment. So we need to give it an index, so an additional variable to store information in, and then we enumerate through our list, which just essentially creates a tuple for every component in here, well, for every item in this list, where the first item is in the tuple is the index and the second is the actual value of that component. Okay, and so when we give it two variables, it then stores the index in I and the actual variable in C. Okay, so now as we loop through, so first of all we want to say, well, we're basically going to say if C does not equal empty string. Okay, because now we're going to check each one. Now look, our username shouldn't be empty, our version shouldn't be empty, our task and our scene, they shouldn't be empty. Descriptor is the only one that actually should be possible to be empty. But we also, this is an additional kind of safety clause. What if accidentally somehow our scene ends up being empty, or our task is somehow removed and turned into an empty string somewhere along the line and doesn't get caught by this error? Maybe our username, because we aren't really checking that, maybe our username has been overwritten with an empty string. Okay, if that's the case, then we need to we need to basically remove it. But also, what if username was none? Like, what if it actually it wasn't initialized for some weird reason? So username now equals none. Now we can add it to this list because user is a variable that we've created and it stores a value, but that value is a Python object none. So we also want to, in addition to just checking if C does not equal an empty string, we also want to check that C is not none. So we actually say if C and C does not equal empty string. Because remember, when we say if C, that will return true if C is anything other than none. Okay, so if user has a value when user is C and it's not none, then this will equal true if C. But if C is none, then if C is going to return false, and so it will break out of that loop, well, out of the this block. Okay, so if C and C does not equal an empty string, then we're going to do something, because we've determined that it does exist and that it's not empty. Now what do? We clean up the name. Okay, but we want to overwrite the component in the list. So this is where we need our I, because we want to take each component out of the list, work with it, and then put it back in. Okay, because I don't want to have to store another list, and throw away this list just for that purpose. So I'm just going to go and overwrite scene with a cleaned up version of scene, which means that I feed it I when scene is C, I will be 0. So this I will be 0. So it's going to go and overwrite the first index of components with the new version of scene. And then when it moves to task, C will be task and I will be 1, and so on. Okay, so I hope you guys are following by now. So we're going to run our function clean name, and then we obviously feed it C as the name to go and clean up. And then as an else to the statement, because if it doesn't exist and if it's not an empty string, it's going to clean up the name. But what if it doesn't exist or it is an empty string? Well, then we need to just remove that. Okay, but we need to remove it from the original list. So we can del components and then I. Okay, now an alternative to this, if you wanted to, was to create another empty list. So you have your components. Maybe I would do something like call it underscore components. Then you'd store your temp values first, but then you'd create one called components, and that would be empty. And then you'd loop through this list, checking each one. If it succeeds this check, then you'd clean it up and append that to your new list. And so at the end, your new list would have only the ones that have been cleaned up and only the ones that were not none and not empty. That is a different way to do it. But I like this because, you know, just by enumerating, we can actually keep the same list and just simply overwrite each component as we loop through it. Right. Okay, so let's move on. Now that we have our list, we know we're going to assemble that, okay? But we also need to, there's one final bit of information we need here, because in addition to these 5 pieces, we actually have 2 others. One, which is the path that comes before this. So the actual path to where we're saving the scene is important to know, but that we already have. That's our save path, okay? So tick. We now have 5 components, or potentially less if some of them are none or empty, and that's the name of our file. But the very last piece of information is, of course, the extension. Okay, so we'll just say set extension. Now, what we could do is just go, you know, extension equals .hip. Okay, but the problem is it's not always .hip. In my case here, I'm using an indie version, so actually when I save my scenes, it's .hiplc, right? You might also have a non-commercial, and then that's .hipnc, right? So instead of just assembling it that way, we're going to actually, so I'm just creating a license dictionary over here that just has a list of essentially the different types and what their extension is. And the reason I'm doing this is because there is a function. Let's jump into Houdini to just check it out, right? So we can say who dot, and then there is license category, right? So we can go to license category. Now that returns license category type dot indie, which is telling you what my current session is in, okay? But this is a license category type. Instead, we want to get that as a string, so there's a name function on that, and so it returns a string of just the end, right, indie. Now, what you can do is you can go and have a look at all of the different who.license category types. If we go dot, you'll see the list, so apprentice, apprentice HD, commercial, education, indie, right? And we're going to list all of those with then the extension that goes along with those, okay? Some of them they share a few in common, so some of them do not have their own individual unique one, but that we still want to know, because that's our only way of asking Houdini what version, well, what license type are you? So it's going to spit that out. So we're going to create a dictionary with then the key. The key is the name of the license category type, and then the value is the extension that we want to use in association with it. So we can go commercial, right? And then that will be just hip. And don't worry, we don't need to include the dot, okay? So we will include the dot in our string formatting, right? If you do include the dot here, then you just need to remember to not include it later, otherwise you're going to end up with 2 dots. Right, indie is hip LC for limited commercial. Then apprentice is hip NC, right? Then apprentice HD still saves as hip NC. And then the final one is education, which also comes up as hip NC. Okay, so that's our license dictionary. And now what we do is we find our current license type, which is who.license category. Category. And then name. And then what we do when we select our extension is we just basically point to our license dictionary and feed it the key of our license, and so it will return the associated value for that. All right. So now we should have all the parts we need to assemble our file name. Okay, and that is what we need when we want to save our scene, is we need to give it a full file name of exactly where to save our scene. So let's build our file name. Okay, so what we're going to do is we're basically going to use string formatting here. So we're going to basically have our path, then we're going to have a /. We're going to have the name of our file, then dot and ext for the extension, right? So that's pretty simple. We're going to do format, then we feed it path equals save path. Our name though, name equals, we need to assemble this. So instead of assembling it in here, that's a little bit messy. I'm going to go and create a separate name. So I'm going to say name equals. Now remember, this is a little bit weird or counterintuitive, but we need to give it the dash first as a string, and then say dot join, and then feed it the list that we want to join using the dash. Okay. And remember, we're now going to just feed it our list of components, and any components that were empty have now been removed from that list. So then name equals name, and then our extension equals extension, ext. Okay. And those are the three that we need to assemble our path. So now we just need to say, we'll just call this one file name. Okay. And that's where it's going to save the scene. So let's just, before we execute the very final thing, which is to save the scene, let's print this to confirm that we've done it correctly. Okay. So let's go back in here. We'll click save. Let's enter magic, because that one has quite a few versions, so we'll make sure that our version number is correct. And then for description, let's give it something, and then we're going to click OK. And now you'll see here what it wants to do is save my scene in this location, which is exactly correct. We're in our new scene under the Rebel Way new test project. We are in the working files folder, which is under scenes. Okay. And so under scenes, we've got our new scene, we've got our working files, which go into that new scene. And then we have our scene name, our task name, our version number, which is incremented 1 up from what it was, our description, our username, and then the correct extension. Okay, so let's jump back in. And now that we're not, actually, do you know what? Let's be certain. Let's run that one more time. Let's put magic in, but let's leave description out. And you'll see here, we've got magic, we've got a version number, we've got 1 dash, and then the username. So that part has worked correctly. If we go and save this as some other task, you'll see that it appears as version 1. And if we go and give it explosion, which was already there, then it'll be version 3 of explosion. Right, or we could do explosion with a description, and then it's going to add that optionally in. Okay, perfect. So now let's just save our scene. So we'll go here, save. Oops. Okay, so we just now need to go who.hip file, so that is the module that we're referring to, and then the function is just save. And then we feed it a file name. So that saves our current scene as the file name, but the file name must be a full path to exactly where we want to save the scene, including the file name and extension, right? I think it will automatically include the extension if we don't, but I prefer to give it the extension, and I think this is a much better way of doing it because we can be very clear about how we save the scene. Okay. Right, so let's double check this before we go back, because there is an additional step that we need to add to all of this. But right now, it should at least be able to function and save our scene as it is. Okay, so we click save. Let's go here. We're going to go back to saving over magic, and let's go give it a description. So this will be our first test. And in fact, I'm going to put a space. I'm going to put a capital T, a 3 instead of an E, and then an ST. Okay, so this should be a good test of our cleanup script, right? Oh, and in fact, we'll put a space at the end and we'll put a space at the beginning to really just mess with this. Okay, and then we're going to click OK, and what you'll see is Oh, okay, hang on. It did keep our 3 because it is actually a word character. Okay, so it will allow us to keep numbers, but if that had been something like a $sign or whatever, it would have swapped it for an underscore. But either way, we have saved our scene in the correct location as new scene magic version 8. So we've gone up 1, and it's got a description. It's cleaned up our description pretty well. It's gotten rid of the leading and trailing white spaces. It's all lowercase. It did keep the number, and it swapped the white space for an underscore. Okay, so here we go. When we open up, we can see exactly how our scene is saved, and it's in order. You see how nice that is, how simple it is and easy to see exactly what you were working on. Like, and these are all the versions. This is what I was doing at that time, and who worked on it. This guy. Okay, cool. And then it can swap to whatever user is next. Okay. So let's. I mean that. Yeah, that basically that works, right? Okay, so let's move on. So the one thing we want to add to this, right, is okay. We go here. We click save. Our scene is already saved in this way. Okay, if we gave it a new task, of course, then we're telling it to save version 1. But if we click save and we already have one, it's really annoying that I have to now type magic again every time. Okay, sometimes I just want to increment, so we need to build our ability to do the quick save, which is just control clicking on save should put it in the same scene, same task, same description, and not even pop up a dialog and ask me anything, just increment the version number. Okay, so we need to build our quick save. And then also, even if we don't quick save, when I click save, I would like to at least have my current task filled in as the task and my current description to be filled in as the description, because it just shortcuts things. Most of the time I'm going to want to increment, so the task being already still magic every time is much more convenient. Okay, magic's quick and easy to type, but what if it's a much more descriptive task, right? Or something like explosion can easily be mistyped, like something like you just get the O and the I mixed up, and now suddenly you're saving version 1, okay, instead of, so this should be version 3, but it's actually version 1 now. That is terrible, okay? So we need to avoid that by, when we click save, it should already pop up with our task, and that way most of the time our user's just going to click OK, and only if they want to change it they'll change it, but then they probably are deliberately changing it to something drastically different instead of, for some weird reason, changing explosion to explosion. Okay, so that's what we want to do. So we need to now use regular expressions to take our current scene name and pick it apart into its component parts so that we can feed those components back in to our script. And then, like I say, we're going to build our quick save as well. But our quick save is kind of based on that same principle, because we need to already know the bits that are there so that we can save without having to ask any questions. All right. So, sorry, let me just set something up here. Okay, so what we're going to do is, after gathering all of our variables, right? So we basically want to, before setting our task and description to just nothing or just empty, we're going to try and fill them with whatever is there. And if we're unable to fill it, then we set them to nothing. Okay, so but do we do it here or do we do it before? So you've got to sort of logically ask yourself, okay, what do we need in order to do this? Do we need to know where the save path and the scene is? Do we need these variables? Well, yes, we do. Because once we know what the scene is from the environment variable, then we can use that in our regular expression. So we know we need to be after this point. Now, could we do it after setting task and description to be empty? Well, technically we probably could, but we would then need to store it as 2 separate variables, check that that other variable is valid. If it is, then overwrite these empty strings with that. Okay, so if you wanted, you could build it that way, and that's totally legit. That's a fine way to do it, and you can do it here after this, but definitely before we get to asking the user, because this is the point where we want to feed that information in. Essentially, our initial contents here is what we're trying to fill in. We want to set task and description to be whatever it was in the scene already. Okay, scene path, the save path and the scene should already be set by the variable, so we don't need to find that. But we need to take our save file and gather the task and the description from it. All right. So we can do it here if you want, and then you'd have to overwrite those, or you can do it before here, and then these will only overwrite task and description with empty strings if they are not set. So either way is basically equates to the same thing. Okay. So here I'm just going to call this, I'm going to say set task and description from current scene or initialize. Okay, so that if we don't successfully do that, then we're going to initialize it to empty. All right. So first thing that we need to do is get the actual current name of our scene file, and that's as easy as going who.hip file. Now in that module there is we have access to a bunch of things, so let's grab and have a look over here. So who.hip file dot, and then you'll see we've got quite a few things, and you can check because there is name and there is path and then there's base name. Okay, so let's see what the difference is there between name. Okay, so that's the name versus base name. Okay, so see, base name does not have the full path, and because we know we already have the path, let's just use the base name. Okay, because this has all the pieces that we need. We're going to pull off the extension, the user, the version, task, and then scene. And we already have scene, so we know how to do that. Okay, so we go grab base name and store that as a variable called current name. Okay, and now we're going to dive into regular expressions and kind of pull this apart. So let's go and grab, sorry, I'm going to open up a browser just to jump into regex 101, and I'll pull this over here so we can see it, and I'm going to grab this string from here, so our current scene, just so that we are using that as a relevant example of how we're going to pull this apart. Now, I'd encourage you, you've had enough time to play with it, so I would actually say pause the video and go and see if you can build it so that we can pull this apart, right? So go ahead and do that, and then come and see if you've got it right. Okay, so I hope you've been able to do that, but if not, here we are. So the first thing we're going to do is obviously grab. So we could feed in our scene name actually in here as a, like we did last time, where we're going to use string formatting to replace it with a literal match to new scene. Okay, but I'm going to go a different route here. Instead of just feeding it that very explicitly, let's just make a bunch of assumptions, because the thing is we know we're in control of the structure of having all these dashes separating it. So why don't we just use that as a way to separate? Okay, so we can use, it's all word characters because it should be. There should be no special characters or anything. And we've replaced everything with underscore. So everything should be a word character in here. Okay, so we know we can use \W, and we know that it needs to be at least one character, but potentially more, right? So you want to select as many word characters as possible. When you'll see it breaks at these dashes, because dashes are not word characters. It also breaks at the dot, which is great. So we want to select as many word characters as possible and put that in one group. Okay, and we then want to put a dash. We don't want to include that in any group. The dash is just filler in between. Then we go and do exactly the same thing. So /w plus. Okay, and that's in another group, right? Then we're going to go and be a little bit smarter here in this next group, and we're going to put the V will, well, okay, look, you can include the V in the version if you want, or so you could put it on the outside, or we can include it in here, but actually technically you could put a subgroup inside of that which has the actual version number if you wanted to. So I'll show you how to do that, just so we can do it a slightly different way so you can learn a little bit more about regular expressions. Now we know we want to grab a digit, and we know we want it to be 3 or more, right? But you see now how those are two different, that's the version, and this is just the version number on its own. So whether it includes or does not include the V is optional, because it's the one group is inside of the other. Okay, so it's a subset of it. And then after this point, now we need to be very careful here, because we should actually put in another example to test this fully, because don't forget that we could have a description in here as well, but sometimes we won't. And so we can't just go and put a dash here, because this dash could be the dash that separates version number from username, or it could be separating version from description, and therefore there's another dash needed. So which bit of this is optional? Okay, this dash plus the description is optional. Okay, that could be sometimes there and sometimes not. Okay, but this dash right before username will always be there. So here, instead of putting the dash on the outside, we're going to include it inside the group, right? So we're going to put a dash, and then again we're going to use a subgroup, so that we can still very easily pull out the description without having to separate that dash description. Okay, so we'll put in here /w plus again, because we obviously just want to grab all name characters, right? Or all word characters, sorry. So we have the dash description as an optional name, and then this as one group as well, and then this has the same thing, but you'll see that'll go away now when we put a question mark at the end of this, right? So what we're going to do, and I think this is actually something I might have forgotten to tell you guys about when we did it the first time. With an entire group, if we go and put a question mark, we make that group optional. So it does not have to exist. It will try to exist, but if it can't find it, then it'll just ignore it. Okay. Now at the moment, putting the question mark doesn't change anything, but if we do put in the next section, so we put in a dash, and then we put in, you see already even by putting in the dash, this first one is now not valid, because it's looking for something and then a dash over here. But if we take this entire group, so the one that includes, so there we go, that one that's got the square around it right now, the fifth capture group, which includes the optional dash and some words. Okay, if we take that entire thing and put it in, kind of qualify it with a question mark, it's basically saying that this should be match 0 or 1 times, as in it can or it doesn't have to be there. And so now when we have that dash, this dash and this dash are the same one, this whole group has been found in this example but not found here, so it just ignores it. Okay, and now we go and end our last one, which is kind of straightforward, is just our username. Okay, and that will always be there, and it's really, really simple, so /w plus. Okay, then we obviously want a dot, but remember, we don't just want a dot, we want a literal dot, not just any character. So we need to put a \dot so that we're very explicit about the fact that it must literally match a dot, not the regular expression dot, which means any single character. And then we have our extension. Okay, so we could, and by the way, if you wanted to include that dot in the extension, then you can. You would just put the round brackets here, of course. Okay, so you'd put the round brackets there, and then include the, so maybe /w plus, okay, and then enclose that, right? So that will then include that whole extension, or what you could do if you wanted to is also again create a subgroup. So then you've got the one option, which is the full extension, which includes the dot, and then you've got the extension name or the extension type or whatever, which it does not include the dot. So you can do it this way if you want both groups, or if you want just the one. It's kind of up to you, right? Okay, and then obviously we want to make sure that that is the end of the string. Okay, there cannot be any other letters after this, right? So we're going to do a re.match, which makes it match from the beginning of the string. So if there's anything in the beginning here, it will not match. Even though in regular expression, so in regex 101, it will match if we have this at the beginning. Let's say we have that, like another section. It's just going to ignore it. Okay. When we do a re.match, it will fail to find here, because re.match says it must match from the beginning of the string. If it doesn't match on the first character, it will fail and just ignore it. Okay, so we don't need to really worry about the beginning, but if you want to, then at the beginning here, we would just put that up arrow. Okay, so you can be very explicit if you want. And then here we're putting what's important though is to put the $sign, because we don't want there to be a possibility of something afterwards. If the $sign is not there, it'll just match up to that point, and re.match will still be satisfied because it's matched from the beginning up until that point. But what we want to do is specify. We want to make sure that at that point, that is the end of the string and there is nothing else. And so when we put a $sign, it fails on this, and that's correct. We do not want this to succeed. Okay. So now we've been able to sort of strip that down into its component parts. Now, I do not like referring to groups like this just with indices, because now I need to go back and check the code to try and remember which index was which. So we're going to rather go and give them actual explicit names, which remember is question mark, capital P, and then inside of the triangular braces, we give it a name. So here I'm just going to call this scene, because that is my scene. Question mark P, we'll call this one task. Then here we have two versions, right? So we can, on the outside, we can call this one, maybe let's call it full ver. Okay. And then inside question mark P, we'll just call this ver. Okay. Then here we have the exact same thing with the descriptor, but I don't think I'm ever going to want it with the dash. So I don't really see myself referring to the full group. So we can just go here and put a question mark P and just name our inner group, but not the outer. So we'll just call this DESC. Okay. And that group, obviously, if it doesn't exist, will just return none, and that's fine for us. Okay. By the way, you could do the same thing here with the version. If you feel like you're never going to actually need the full version, then don't even bother naming it here. You can just remove that. But I thought I'd show you an example of where we do name it versus where we don't, just so you can see how they are structured slightly differently. And then here at the end, this is our username. So it's question mark P user. Okay. And then at the end, after our dot, this is our extension. So question mark P and then ext. Okay. So now when we look at our match information, you'll see that the full match matches that, which is correct. It grabs the entire thing. The scene, task, full version, which includes the V, version or ver, which is just the numbers. But if you wanted, maybe you could call that version and version num, or whichever way around you want to do it. The username, there is no description in this case. And then the this group, which is not named, we could name that if you wanted to over here. You'd then go insert that name, all right? In this case, I don't think I'm going to, because I actually don't really need that. I'm going to grab it this way. Okay, so I've named this one and not named this, but you can name it if you'd like to. Okay, and here in match 2, it'll show us that with an optional descriptor, it will still pick that up. So it still picks up version as version. It picks up the descriptor as the descriptor, and then it still picks up username as username. So even though it's technically in 2 different places, after this version number, this dash, because of the way we've structured our regular expressions, it knows that the very last thing before the dot is the username, and this group is optional. So when it finds a dash here and nothing afterwards, it knows that that is not the descriptor, it's the username, and so it picks up username correctly on both examples. Okay, so this is the absolute power of regular expressions, is how it can kind of know and be intelligent about the way that it dissects strings. Okay, so very complicated example here, but something very practical and relevant. So I'm now copying my regular expression. We're going to go insert that into our code. Okay, so I'm going to store my regex, and then I'll feed it this string. Now, because here we're not doing any string formatting, I'm just going to put an R at the front and just call this a raw string. I don't know if there's anything in here that will cause issues, but I'm just on the safe side, it's just easier to put an R. And then obviously this goes over the edge, so I'm just going to split it at a certain point. I'll split it over here. So we can just hit enter and it pushes it to the next line. It puts an R for us automatically. So, you know, PyCharm's pretty cool that way. Right, so now that we've got our regular expression, we're going to say match equals re.match. All right, so we're doing a match, not a search. So we're being very careful about matching it from the beginning. And then we're going to feed it our regex. And then we feed it our name, which remember we called it current name over here. So current name. And then we do want to, just in case the user has manually named it and trying to match our naming convention. Maybe they've done well in matching it because of the dashes, but maybe, so it has succeeded in matching, but they've got maybe capital letters or something. Maybe they went and named their username with a capital letter or something. We don't want to completely fail, we just want to fix it after that point. So we're going to gather the information correctly, but then when we save out, remember we fix the name anyway. So from the very next version, as long as they save using our tool, it will fix and make everything lowercase. So I'm going to allow the flag of re.I or re.ignore case, whichever way you want to go. Okay. So now we will say if match, because obviously if it hasn't matched, then we're not gonna do anything. Okay, and we'll get around to the some task and description for now. So for now we can just ignore those two. Okay, but here we say if match, then so we say if not task. Now the reason I'm doing this, okay, let's just, this is kind of taking a little bit of a step ahead, but we do need to kind of sometimes try and think a few steps ahead when coding. What I want to do is I actually want to give some arguments to this save scene, and if we ever want to build a tool that allows that maybe forces the scene to save itself, but without the user having to fill in information, I want to be able to run this whole script just from the right arguments. Okay, and so instead of asking for an input every single time, I want the option of providing a task and a description, and so it won't ask, which also is what we're going to be doing with our quick save, is we're going to say no, don't even ask, I'm just going to give you a task and give you a description name, and you're just going to gather it. Okay, so I'm going to allow here some two additional arguments, which is task and description, but by default they're going to be none. Okay, so task and desk equals none. So if we don't do anything, we just run our save scene, everything will be fine and it'll just do everything as normal. But if we run the scene and force it to have a certain task and description, then we inside here we're going to be kind of ready for it, and we're going to say, okay, something, probably not the user, but some tool has run and triggered this save scene and has given me additional information of the task and description. So I'm going to I'm going to do the same stuff, but maybe just a little bit differently. So I'm not going to pop up and ask the user to name the scene or whatever. I'm allowing some sort of code to run this script in the background. Okay, so that's what we're kind of building for here. So we only do this if there is no task, right? So in other words, if task is none, then we override it here with whatever we find from the current scene name. Okay. So we say if not task, then task equals, because we want to overwrite task, so task equals, and then we just go match.group and task. Okay, so remember we're just grabbing our match object and grabbing the group from it, and we know it's called task, so we want to grab our task. We're going to do the exact same thing for the description. So if not description, then description equals match.group DSC. Okay. Now that was not to say that there was that maybe the description that was fed in here was empty. This saying if not description is saying if it was none. If it has been overwritten, fed in here as an argument with an empty string, then it will not do this and instead will then take the description as it is. So DESC will be set to be equal to that empty string. Okay. And now, outside of this, we do that test again, basically, because obviously if there was a match, we're doing the overriding, or we're asking whether we should override task or description. But outside of here, we also want to say if not task. So what if there was no match? We haven't saved the scene, so this match fails. So this whole section just does nothing. Okay, I'll disable it for a second to just show you that that does nothing because the match failed. We haven't, let's say, saved the scene before. It's a brand new scene. Well, we still want to check whether this task has been fed in as something to force sort of an override, or whether we want to do the normal user version. So in this case, we say if not task, then task equals an empty string. Okay, and if not description, then description equals an empty string. Because remember, we do need to initialize them to something. Okay, because the script was complaining earlier on in the previous lesson about having nothing as a task and a description, because it's inside of a loop here, so it doesn't know that we're going to set it every time. So we need it to be set on the outside, but we need it to only be equal to an empty string if the user or the script in the background does not force the task and description to be something. If it does, then it mustn't be overwritten with an empty string. We must just keep task and description as they are. And this will be set to an empty string only if the match fails, which means that it's not saved in our current naming convention. If it is saved in our current naming convention, match will succeed. It'll say if match, that'll be true, so it goes in here and then it says, all right, I'm going to override task and description with whatever I found from the current scene, but only if the user has not provided task and description when running this function. Okay. Now our shelf tool does not provide task and description. So clicking the shelf tool will never cause task or description to be anything other than none. But like I said, we could have maybe on our on our scene data node, we could have sort of an auto save feature or something, or it could trigger like a count in the background and it'll say every 5 minutes it'll auto save. Now when it auto saves, maybe we wanted to force increment every time it auto saves. But we don't have, could you imagine every 5 minutes this thing popping up to ask you to give it a task and a description? That would be really annoying. So if you wanted to build an autosave feature, your autosave would run the save scene function, but it would feed it task and description as something that it deliberately wants to give it. Okay. All right. Now, what we need to do to get the control click kind of quick save thing working is, there's a couple of steps here. First of all, we need to check whether it has been control clicked or not. Okay, so we kind of need two modes, and we need to know which one the user wants at the moment. And I always like to use control click to do the quick version of a shelf tool, and then shift to do the long version if there is maybe a very forced long version. Okay, so it's kind of the equivalent of like quick save versus normal save versus save as. That's sort of the idea. And in order to know whether they've control clicked, we do need the Quargs dictionary. Okay, but I want the Quargs dictionary to be fed in as the first argument. Okay. Now, I can insist on receiving this Quargs dictionary, but if I do, then I'm kind of getting myself a little bit stuck, because if I want to trigger, like we were saying, trigger the save scene maybe automatically or through some other tools and give it a task and a description, well, then I have to feed it Quargs. But the problem is, if I'm not running it through a shelf tool, then I don't have the same Quargs as a shelf tool has. Because remember, when we click a shelf tool, it has a bunch of, like, a keyword argument dictionary. It knows whether it was control clicked or shift clicked or whatever. But what if I just want to run that save scene function right here in my scene? Like, I want to literally say from save scene import main as save, and then go save.save scene, okay, and trigger this, but I want to feed it the task and description or something. So I want to like kind of do a force manual save, okay, which I can do, right? So if let's go over here, let's take our Quargs out for a second and just show you that this does work, right? So if we have our function in there, and then we can just forcibly run that function, but we can even feed it a task and a description. So task equals magic, and description equals, maybe this will just be our force test. Okay, so, okay. Hold on, it hasn't reloaded, right? Okay, so we haven't reloaded it because I'm thinking, hang on, it does take 2 arguments. We do need to reload it, so we go reload save, okay, and now when we run that, it is going to fill in automatically those 2, okay. Now obviously there's an additional step here, which is to make it not pop up with the dialogue, but we haven't built that yet. But the fact is, we can feed it certain explicit information that needs to pop up in here, and then just say okay, and now it has saved correctly. And obviously we can skip the dialogue as well and turn this into some function that could maybe be automatically run every 5 minutes or whatever. Okay, so that is sort of where we're at. But the problem is that function, running it from here, does not have Quargs. Okay, if I, like right here in this terminal, if I print Quargs, okay, it says Quargs is not defined. It doesn't know what Quargs is. But if I do it from the shelf tool, then it knows exactly what Quargs is. Okay, so we're sort of stuck here a little bit, where if I force it to give me a Quargs dictionary, then in order to trigger it through the terminal here, I would have to deliberately go and like maybe run this function, but then feed it a false dictionary. So I'd give it maybe an empty dictionary, or if I know that it's relying on the control click, and then I'd have to feed it maybe false or true or whichever one, in order for it like to be satisfied that I've given it some kind of fake version of the Quargs dictionary. That's not really a good way to do it. So our way around this is we're going to kind of give a none as a default to this. So we're going to allow there to be no Quargs dictionary, but if one is fed in, then cool, we'll happily accept it, right? And we'll change our shelf tool to feed Quargs in. But here we're now going to build a little bit of a safety catch for if it cannot find the Quargs dictionary. So if none is provided, well, we know inside the script itself, you know, because maybe the user is not the same person building the script. So we as the scripters know, okay, all we're looking for is whether it was control clicked or not. So I'm going to build a variable called CTRL to say whether it has been control clicked or not. But that is going to be built like this. So I'm going to say if Quargs, so if a Quargs dictionary is fed in rather than none, then CTRL is going to be equal to quargs and then ctrl click like that, right? If you print your quargs when you run a shelf tool, you'll see that that's what it's called, is ctrl click like that, okay? But if we don't find a quargs dictionary at all, well, we are just going to force control click to be now equal to false, so ctrl. So rather than relying on this variable, we're only using it to then set our own variable. Okay, so now if we went and forced this to just be none, or just didn't provide the quargs dictionary at all, well, then it's just not control clicked. Okay, right, so that's that. Now the next step here as well, so basically what we're going to do is we need to use that control click, whether it was clicked or not, you know, like, or whether there was no quargs, then we know it, the control is false, to determine whether or not to actually ask the user for an input or not. Okay, because we don't want this to always pop up, and sometimes when if we're gonna provide a task and description, run it in the background, or do our quick save, we need to be able to say, well, just, you know, don't ask, just do it automatically for me. Okay, so I'm going to do it here just before asking, is we figure out whether we should or shouldn't ask. So I'm going to create a variable called ask input. Okay, and I'm going to make this true because we should most of the time automatically be asking for input. Okay, and then I'm going to take this entire block over here, this section where we're asking for the input task and description, and set this to be if ask input, then do that, right? So very, very simple, just based on a variable. If it's true, then ask. Okay, but we can now force that to be false. So we're going to say if ctrl, so if control, because if control is true, if we control clicked, then it mustn't ask. And if task does not equal an empty string, okay? Because even if control click is clicked, even if we like literally, you know, control click our shelf tool, we cannot just automatically save with no task. So unfortunately, if there is no task name for some weird reason, like for example, if we're on our we've got a blank brand new scene, so even our re.match would like fail over here. So then we have no task. Okay, we either haven't provided a task, so task was none. We then tried to do the rematch and it failed because we haven't saved it already with the naming convention. So task is still none. So then it says here, if not task, then task equals empty. So we go, okay, so now task is an empty string. When we reach this point, we're saying, well, if task is empty, I can't auto save this. I can't quick save it. I have to ask you to give me a task because we insist on that naming convention. Okay, so this is the only additional clause. It's like, yes, sure, I'll quick save for you if I can, but if you haven't given me a task, then I need more information. Right, so if those two are met, then ask input can now equal false, because now we can skip. And we can skip because ultimately asking for the input is doing only two things. It's filling in a task and filling in a description. Descriptions are optional, so they don't have to be there, but also assuming that we've control clicked and we've maybe successfully matched. If there already was a description, then DESC is now equal to that description. So if there was a description, we've already got it, and we've already got a task, and we already know the scene and the path. We can calculate version number automatically, and we already know the username, or we can figure it out through the variable, and we know the extension. So we actually have, at this stage, we have every bit of information that we need, unless task was empty. So as long as we check the task isn't empty, then we basically are able to skip this whole next section. Now it's nice to allow this next section, and that's why our normal save will ask, but this is only a formality. And now because we have our initial contents set to task and description, when we do still ask, it's filled in automatically with what we've assumed will be the task and the description, because we're just assuming that task and description will stay the same. Now, yes, description should actually change in almost every time you save, because you should be sort of working on different things, and you shouldn't be lazy when you when you use this tool and just give it like no description every time. That's just using half of the functionality. But if they want a quick save, then they don't want to have to fill in a description. So we just allow it to be whatever it was, including if it was non-existent. Okay. Right, so let's double check that this all works, and then that should wrap up that tool. Okay, so we're going to click save. It already, because that was, look at our scene, it's called Magic version 9 Force Test. So it already picks up Magic and Force Test, fills them in for us. We can click OK, goes to version 10. Now, obviously, if we control click this, it's not going to do anything because we haven't fed in the Quarks dictionary inside of here. So let's come in. We're going to feed it Quarks. So we're going to say, we can just do this because it is the first argument. So we can feed it the Quarks dictionary. Or alternatively, we could provide the keyword name, so the keyword argument, which is called Quarks, and then feed the dictionary into that. And then obviously there is the option of task and description. Okay, so for example, if you wanted to set it to a version, like maybe create like a button for someone, like an alternate to this tool where it would not ask for description, only tasks, you could then build that in here. So then maybe description is just equal to an empty string or something. Okay, so there's lots of options that we can do, but for now we can just feed it Quarks, and since we're only doing that, I don't really feel the need to go Quarks equals Quarks. We'll just feed it the Quarks dictionary because that is the first argument. Okay, if it was the second argument, we would have to give it its keyword, otherwise it wouldn't know where to attach that information. Okay, so now when we click that, works perfectly fine. If I control click though, then you see it just increments the version because it has all the information it needs, and it just saves with the exact same task and description. Left click normally, pops up automatically. Change this to something else, and it's going to go and save that as version 1, but it keeps my description. Okay, and we can take the description away completely, and then it moves to version 2 but drops that description because it's optional. Control click, goes up to version 3. So everything is working perfectly. All right. So thank you, everybody. I hope you've been able to follow up to this point. Obviously, if you're confused, don't be afraid to ask questions or go back and have a look at what we've done. But I would very much encourage you to use this tool in your daily life. It is, it's really good to follow a naming convention for your save scenes. Okay. So thank you, everyone, and I'll see you in the next lesson.